Alright, so now that we've been working with series for a little bit and sum or sequences, we are going to go ahead and now actually learn some rules for formulating these. So before that, I'm actually going to walk through some of these examples, and then we're going to go back to what this idea of common differences and formulas. We're going to actually think about how to get them. So, writing the first 5 terms of each sequence. Let's do this first one by hand. So A1 will equal negative 4 times 1 minus 3, which will give us negative 7. A2, so we got negative 4 times 2 minus 3. That'll give us negative 11. A3, negative 4 times 3 minus 3 is going to give us negative 15. A4 equals negative 4 times 4 minus 3. That will give us negative 19. And A5 equals negative 4 times 5 minus 3, which gives us negative 23. Well, let's notice something here. How many am I going up by each time, or down by? Well, hopefully you kind of look at it and say, I'm subtracting 4 each time. Well, if you're subtracting 4, look how there's a negative 4 in this series, or in this sequence. It all connects in here. Well, I can write the rule for this. We'll actually come back to that in a second. Alright, now let's do a refresher here on how I could just do this in my calculator without doing anything. So remember, you can go here, go to that second catalog. So second 0 gives you the catalog. Press natural log to get you to S's. Go down. I want the sequence of events. I'm using the formula negative 4. So negative 4 plus 3 times x minus 1 I'm going to use. Alright. I am calling x, and I want the first 5 terms. So I want 1 through 5. Alright, and it gave me it there. So, first 5 terms, I've got negative 4, negative 1, 2, 5, 8. So, term 1, term 2, term 3, term 4, term 5. Well, let's look at how we change from one to the next. So, what's going on here? Well, hopefully, again, you realize I'm adding 3, add 3 more, add 3 more, add 3 more. Well, sure enough, 3 is here. Well, hopefully, maybe you realize this too. In this case, there's a negative 4 here. See how that matches up with the first term? Well, you bet that's where we're going to derive our formula from. So first, let's talk about a common difference. Well, we found that. That's at negative 4, the positive 3. It is the constant difference between terms. Alright, now let's actually talk about the formulas. Well, for an arithmetic sequence, so arithmetic the general formula is AN equals your first term plus the common difference, so that's your constant difference, times n minus 1. Now, something we're going to talk about today is how to find the sum of a series. The sum of a series, so then going ahead and saying sum of a sequence, which really becomes a series if you're adding the sum, is the formula Sn equals, you take n divided by 2 and add the first term plus the nth term, or the last term. And you may have done this before where you actually added together the numbers 1 to 100. You can go ahead and try that on your own and figure out what it is. Alright, so these are two key formulas that are going to help you on tests and quizzes. Let's go ahead and actually find the sum, or let's find the formula generated by using 4. So my D equals negative 4, A1, we got negative 7, and what else do we have? How many terms are there in this? Or no, we don't want n. So let's use that to write an. So use that to write an equals a1 negative 7 minus 4, because it's a negative 4, times n minus 1. Well, that really becomes negative 7 minus 4n plus 4, which then, sorry, I'm running out of room here, an equals negative 7 plus 4, well, that's negative 3, minus 4n. Well, hey, notice that that was what the formula was that we started with. Alright, another thing we can do here is we could find the sum. I'm actually just going to make us find the sum here. So let's use Sn equals the sum, n terms. Well, how many terms do we have? We have 5 terms. So 5 over 2 times a1, negative 4, plus the last term, 8. So equals 5 halves, 4, and then that's going to end up equaling 10. And sure enough, if you add these 5 terms together, you're going to end up with 10. Alright? Maybe you saw it coming, maybe you did not see it coming, but this one is yours to try. So you try this one here. Find the terms. You can either put it in your calculator, and then it says now find the sum. Well, we already found the sum of the first one. You can find this by hand, so actually adding the terms using your Sn formula, or I kind of want to talk about another one. Since you learned how to write sums, you can do the sum of x equals 1 to 5 of the series for n minus 3, and put this in your calculator and it will spit out the answer. That's another way. So again, if you need a quick refresher here, sum on the newer calculators is actually under math. You go down and summation is 0. If not, then you go to your second catalog, and then you need to find summation. So again, you go to natural log, but instead, you need to find it through the catalog list. Alright, so now before we part, we've got 2 other things we need to talk about here. Writing the nth term formula that generates it. Well, didn't we just talk about how to do that? First thing you need to do is find D. So find D, the constant difference. So let's look at this. It goes up by 6. Does it keep going up by 6? It does. So let's write the formula. If D equals 6, A1 equals 0, so we know an equals a1 plus d times n minus 1. Alright, so an equals a1 is 0 plus 6 times n minus 1. Well, that one's simple enough. An equals 6n minus 6. Alright, and we found that. There we go. Alright. Second one over here. Looks like we're subtracting 7 maybe. Keep going. Looks like we're subtracting 7 still. Still subtracting 7. So D equals negative 7, common difference. A1 equals negative 2. So again, use your formula here. So an equals a1 is negative 2 minus 7, because it's plus a negative, n minus 1. So negative 2 minus 7n plus 7, which then equals an. Negative 2, we've got, what is that, 5 minus 7n. Now, I also like to see it so that n is first, so negative 7n plus 5. Again, it's not wrong this way, but I like to see it in order. Alright, here we go. You try finding A13 for both of those. So we should have A of 13 equals and A of 13 equals. So sometimes you're going to be asked to find a requested value. This says to find D. If I have A1, I have A20. Well, let's use that formula. AN equals A1 plus D times N minus 1. Well, what parts of this formula do I know? Well, I have A1. I have A20, so this could be my AN. So then, what does N equal? N equals 20, and AN equals 82. So fill in your slots. We've got AN is 82, which equals 6. We want D, we don't know what it is, and N was 20, so 20 minus 1. So we got 82 equals 6 plus D times 19. And now, all I need to do is solve. So subtract 6, we get 76 equals 19D, divide by 19, divide by 19, D should equal 4. Alright, again, here's yours to try. Again, very similar here, using A5 equals 13, A1 equals that. You're going to want to find D first, then find A6. So find D, then do A6. Otherwise, you can't really get there. Alright, last one. This one has a summation. If I want the sum of this series, I need to be able to find out how many terms. So, how many terms? Well, I don't know. So, let's go ahead and actually find D and figure it out. Well, notice I've got A1 here. This is AN. I don't know how many terms, though. I can find D, though. Think about how much this is changing between terms. Well, it looks like I'm subtracting 6, subtracting 6, subtracting 6. So I've got a D of negative 6. Now I can write the formula since I have A1 equal to negative 1. So ultimately, AN will equal A1 negative 1 minus 6 times N minus 1. Well, I know AN, I know the end. I have it here. So put it in. We've got negative 73 equals negative 1. Distribute, so we got negative 6N plus 6. Well, negative 73 equals 5 minus 6N. Subtract 5, negative 78 equals negative 6N, divide by negative 6. I'm off the screen, my bad. And you get N equals 13. So now you can do this one of two ways. We can go ahead and use the sum, so Sn equals your sum, how many terms? 13 over 2 times A1 negative 1 minus 73. So you can do that, or you can calculate it by hand by finding all the terms. That could be hard. Or we can write a summation, where N equals 1 to 13 of the formula we found. Well, what was the formula? It was 6N, negative 6N minus, or plus 5. Negative 6N plus 5. So that equals, or this equals, and in the grand scheme of things, they both will give you negative 481 as the summation of that. So again, two different ways you could go ahead and find that sum. Alright, so make sure you finish up those U tries in there and bring those to class with any questions you may have.